unfortunately there's not so many ways to get kind of consistent or compressed package of information, or just like an introduction, and this is what actually we're trying to do here. So we will try to give you a basic idea of what cryptocurrencies are. We will not go all the way down to the technical level, so bear with me. I'm myself not a cryptographer, so I couldn't also give you all the way down to the last details on how things work, but I think I have a good overview understanding. Me myself, I'm actually invited here because I used to administer this place, the co-working space Tallinn, that is kind enough to host us tonight. And I'm now a sysadmin in a startup, small company, working with mainly with hardware and networks. And we together, me and Otto the Vogt, who is sitting over here, had this idea that we got so many questions, from people that what this thing is, that we should maybe try to make a public event out of this. Because, and this is the full disclosure before, I didn't tell you that, I will tell everybody that, but Otto is running btc.de, which you should know before. Just to put all the information into perspective, and he lures you into the over-the-counter portal, but we come to that later. Otto is also a software developer and architect and software architect, and he has also a whole different perspective. So we will try to answer your question from as many different angles as possible. My personal relation to crypto coins is probably the relation of so many. I've started too late. I started mining Litecoins in April last year, when the difficulty was still very low. We're now at the tenfold of the complexity, but it's still, according to the economic development, it still makes sense. Bitcoin was never an option for me. It was only an option for people that mined basically from 2009 until 2011, let's say, on kind of a private level. And right now, without a strong investment, there is probably no point in getting into the production. But anyway, all of those things we'll touch later. What we're trying to do today is basically to make things easier and more graspable. We will try to create an analogy of money and crypto coins. We will then scratch the problems of digitality, or the thing that crypto coins are just not there to grasp and to touch. We will show the common ways of production, trade, and use, and then we will also touch some other things that you might have not heard of yet, because Bitcoins, just to make this very clear, are just one little piece in a much bigger concept. And now I have to revert to the most to hopefully get this thing to evolve next level. Okay, so first a little bit to the theory. Why are crypto coins valuable? And again, the analogy to money is probably the most, it's not very correct, but it's the most practical here. So what I try to do is I try to come up with 3 points that make it understanding for me, and then I always compared how current money, in this terms dollars, are doing it, and how the bitcoins, for example, is doing it. So first of all, money for me is representation. It means money is nothing natural, money is man-made. It means that when we have a coin or a piece of paper and say this is money and everybody agrees to it and cherish that idea, then only then we have money, and then only we have the value attached to this piece. In terms of dollars, or in terms of practical currencies, it's quite simple. You have usually coins and bills, or sometimes only bills and only coins, that basically show you a number of its value, and that's basically it. Now, for cryptocurrencies, just imagine that both parts are a piece of data. So the value is basically a number. Can be from Bitcoin has basically is a floating point number. That means it's point, and then it has eight integers, 8 digits after the dot. So until, well, basically this, you can split up one coin into these pieces, which is a millionth or a billionth of about 100 million. So you can split up basically one Bitcoin in 100 million pieces. And this value, you have to imagine, is attached to another value, which is called the public key. We'll come to that back later. Maybe one question. Who knows basics about public key encryption? Who has ever heard of that term? Okay. So we will definitely go a little detail later on. So that to the money being representation. Now, money is also scarce. And that's one of the very important points, that money, not the paper, and probably also not the metal is scarce, but when money is produced, it is minted or it is issued by a bank, it is a scarce and usually in the best case also a finite amount is in circulation, and hence there's an understanding that this is nothing endless. Now, the scarcity comes by one fact because of the minting or printing that take the resources. For like common currencies, that is usually done by the central bank. For the dollar, it's the Fed. As far as I know, for the euro, it's the European Central Bank that have mints to produce those things, and then they issue them. But all of those notes are catalogued, so you will always know when you have at least the notes. Yes, but there's a certain badge you can definitely identify every unique bill. Now for the bitcoins, this is a fundamental difference. Bitcoins or crypto coins in general are not getting issued by one central server, program, software group, software company, or whatever. But they are getting produced by every single client inside the network. And all those clients are on the same level. This is very, very, very important to understand, that none of those clients has any more right to produce a coin and call it a coin than any other in this network. And how that works, we will come to these details a bit later, is that the client in the network produce a transaction, and this is basically how you, here again, with the leap of faith to understand what that coin in that sense is not a really good term. Is that how bitcoins are made is basically a piece of data, the public key, gets associated with the value. And then you have your coin. So you don't actually have any tangible coin or any file where it is written down, but only the transaction that a key, that the public key gets associated with the value, only that makes the coin. And again, I will explain these kind of how that actually happens, and will explain it later.
But explain how it is scarce as well.
How it is scarce?
Bitcoin.
Yeah, of course. How this is scarce is because because inside the source code of that client that everybody has, that is distributed in this network, there's a condition that there is only so many coins to distribute, meaning there are only so many values to attach to a public key. And in the case of Bitcoin, this is 21 million.
Yeah.
Right?
But the scarcity is artificial.
Yes.
It could have been 25 million.
It could have been 25, it could have been a billion, it could have been 10.
Who sets that number?
That number had been initially set by the developers of the program. And that number is also theoretically changeable.
By who?
By the programmers. And that become here, I will explain when we come to the problems of the network, of what is needed in order to actually have this working, this change, or whatever they do to change consistency.
Developers are the de facto central bank.
No. No, but this you will only understand it.
All the machines together are the central bank.
One second.
Do you want us to hold our questions until the
Yes,
end?
please, because I know I understand it a lot of it.
Can you explain mining like now or later?
It will come. Mining will come. Okay. But let's keep on with the analogy. There will be one more point about why cryptocurrencies are basically valuable. Because that is also a very banal fact, but money can only be spent once. For your practical money, for your dollars, that means you can only give them out once and not twice. For digital, and whoever thinks a bit about files and data in general, that's quite a tricky concept to have a piece of data only one time. This is also one of the fundamental innovations of the Bitcoin network and of cryptocurrencies in general, to be able to make, so to speak, make data unique by having the value that gets assigned from one key of one person to another key of another person, for example, to have this transaction be unique and never reversible. So those 3 points, at least from my approach, there's a lot of other approaches on how to explain it or how to handle it in money theory, but I'm not going to go any more into that, is that cryptocurrencies can be considered as money, not as currency. There's a really strong difference here. As money, maybe something between gold and money, or like a value safe and money, because although they are only data, cryptocurrencies have to be produced with resources. They cannot be randomly copied, and they can only be spent in one single time, and hence they can carry value. So, that's to the theory.
I would say there's one fundamental thing missing, is that they are not only the valuable pieces themselves, but it's also the transaction network, because it's also, in a sense, like a network of banks. So you can transfer the money between all the clients around the world, which means basically what the banks do.
Liquidity.
Yeah, in a
Transaction,
sense that they can be transacted, but of course, any other value resource can be transacted in that sense. It doesn't make it unique, or it does not necessarily make this thing a money, just because I can.
Yeah, but this is additional feature.
But of course, the feature that we get to. Now, how it's being done. Again, I'm trying to follow the structure from before, so I'm starting with the representation. But I already said public key and value, public key plus value equals one transaction, which is the actual coin. To understand, or to start to grasp the idea of what a public key is, we make a little excursion to public key cryptography. Basically, the problem is, how do I make sure that the value that I connect with some other some other data is really from me and can go basically into the public, and somebody else can definitely verify that this value, yeah, I've transacted this value to you, and this is all, let's say, true. Is that how it's being done? Is via the concept of public key cryptography. I'm not sure how much it makes sense to really explain this right now, but I will just run through it in order that we have heard of it, and maybe you can make sense of it later on when we get to the practical mining process and transaction process. Public key cryptography is based on that I, for myself, want to send a letter to Otto and want to make sure that only he can read it. What I do is I create a key that has exactly two parts that fit together, and only those two parts fit together. I give Otto one part of the key, and I'm sorry, I should have actually started the other way around.
But you want to send me a message. This if I want to send you a message.
Let's say he wants to send me a message, and we want to have this. We want to have this secure. So what I do is I create a key that has two parts. I give him one part, and I retain the other securely with me, and I never show it to anybody else. the part I give to Otto, I can basically distribute it in a newspaper. It can be public, everybody can know it. What Otto does, he takes that key and he encrypts the letter that he wants to send to me with this key. Now this piece is encrypted, but it cannot be decrypted with this key. It can only be encrypted. Hence now the letter is secured. And only I have the second part of the key that then actually can decrypt that letter again. You follow so far? Actually quite simple in that sense. The technicalities, how it's being implemented, and how that scales through the whole network, those are the complex parts, but those we will not necessarily explain today. So basically what I do is when I want to send Otto some bitcoins, is I take an arbitrary value of, I want to send him 10 bitcoins. This value with a couple of other little information which are irrelevant meta information, this package gets encrypted with his public key. And then I distribute this message into the network, and only he can then actually convince the network that this is his data, because only he is in the possession of this private key. All this key management is done by the software, and every person doesn't have to worry about this. So this is the basic how transactions work. What is actually happening inside that network in intervals of 10 minutes in terms of Bitcoin network is the creation of so-called blocks. And a block is basically, again, a data package and a sum of those three parts. It's a work solution, which is called a hash function, which is basically a proof of work. And I will also, again, have to postpone it to later when we come to the mining process. It's the solution to this, to basically show that I have done some work, or my computer has done some work, plus a list of all the transactions that had been published inside the network over the last 10 minutes in a certain priority list, plus the public key basically encrypting the whole package, and this we call a block. And just also for later to understand, the first transaction in every block that the client mines is the incentive, is the so-called mined bitcoins, currently at 25 bitcoins per block. Now we come to the scarcity, and here the proof of work, the hash function, is very important, because theoretically, to collect for one client in this network, to collect all the lists of transactions that happen, and to encrypt those, make them secure, and distribute them again into the network, create a block, hence, is quite simple. And especially because the computing power is very variable, depending on how many clients are in the network. It can fluctuate quite well. So what has to be done in order to keep a certain consistency, and the consistency meaning that right now in the Bitcoin network, only approximately every 10 minutes a block gets solved, with all the transactions in that block being legitimate, is that a proof of work with a variable difficulty has to be solved. And this is the difficulty that you might have heard of in this talk. That is constantly growing, because more and more computing power gets into the network. Because this difficulty is adjusting and keeping the production of a finite amount of bitcoins at a certain level, this is the technical implementation of the scarcity. There are secondary points that contribute to the scarcity, which is the losability of bitcoins that you lose because you delete the association of the public key to a certain value in your so-called wallet file. They are gone forever, and they are not recoverable. And of course the amount of coins, but as I said before, this is variable in different coins. Bitcoin has this around 21 million. The Litecoins, which is an alternative cryptocurrency, has 84 million, and it's a total arbitrary number. But because of the finity, finity,
Finite.
the finite number of it, that defines part of the scarcity. Now, the last concept of, and what I said before, the tricky part of making data unique is one of the main reasons why we have bitcoins or cryptocurrencies in general as a peer-to-peer network. To solve the issue that money cannot, or money or coins should not be spent twice, what the developers of the Bitcoin network did is they made it completely transparent. That means that from the first the creation of the first block of 50 bitcoins, way back in 2009, every single transaction that has ever been done, meaning every reassociation of a value to a public key and its reassociation to another public key, meaning, for example, sending bitcoins from me to Otto, is being written down in one single file, so to speak, which is called a blockchain. And all the blocks that have been created are interlinked in this chain to each other. It means that every block that is being generated in this very moment is ultimately linked to the rest of the chain, which is right now about 8 gigabytes in the size. And whenever somebody is trying to change anything inside the chain, the complete chain would become a paradox, would not make sense anymore. And this is so basically when I have a history of my transaction that I ever did between Otto and me of bitcoins, all what the client is doing, or what every client or every wallet or every program that can show you this kind of transaction is doing, is scan this file of the public keys that we provide. So whenever these clients find the association of the value with the public key that we provide, it says, okay, there was one transaction. This public key is not associated with our names or our persons, it's only associated with our private programs. Hence, it's still anonymous, but it's in the plain open. It's anonymity in the plain open, so to speak. Yes, and of course, and this is the other fundamental difference to any, especially any electronic money, and whoever uses PayPal knows about this. When I make a transaction in PayPal, I can dispute that. I can go basically to PayPal South and say that, we had the contract, but it didn't work out, so can you please give me back that money? And they can do that, but they can do that on the technical level inside that network. A Bitcoin or a crypto coin transaction is always final. It can only be reversed in terms of I can send again the money and then this would be a new transaction. But a transaction is technically not reversible. That's why it is very important to be certain about the public keys that you have from your partner who is supposed to receive your bitcoins. To translate the practicality into how it actually works in the programs. Let's look at the tools. And what I basically said before is to understand is that the crypto coin networks are peer-to-peer networks. That means that they have a flat hierarchy. All the clients have the same authority inside the network. And the whole network actually, and this is also sometimes very hard to understand, but it only exists because computers are running this program. If all the computers of the Bitcoin network would stop executing this program, the Bitcoin client, the network would cease to exist. So that means that when I want to change anything in this network, any parameters of the network, any of the final amounts, of how big the block is, how long the transaction span is, and these kind of things, I have to change it directly in the client software. And then, of course, distribute it into the whole network, because otherwise there is no other channel of communication inside the network. Those clients, or wallets, clients, there's a lot of uncertainty about the lingo and the vocabulary here. But basically, usually you hear wallet or you hear client. So you basically join that network, the cryptocurrency network, by installing and running this client. That client takes care of the peering in the network. That means it starts to basically search on any network that you're on of common peers. It is your wallet. That means it stores your private keys, and it's usually also the tool to make transactions. And it doesn't have to be, but it also usually is the tool to actually do the mining or do the actual calculations to generate and verify transactions that happen in the network. What is also very often talked about, and what is not completely clear, is what is the difference between solo mining or pool mining. Basically, there is no real difference here. You just have to keep in mind that if all of those clients are working on calculating and approving transactions made in the network, they have to solve. They have to show a proof of work, which is the solving of a very particular function. And when they solve it, a block gets approved, a block gets signed, and because of the first transaction being the incentive, as I said, as of now in the Bitcoin network, 25 coins, the client gets basically the full reward of doing that work. And what happens because of the effort of solving this function being basically infinite right at the moment, what happened is that there's a particular software written in order to focus a lot of those clients into one, so to speak, into one client that then solves the same function but within with the proportional amount of the computing power. That is basically what happens inside the network. What is now already outside the network, where coins in general get traded, is initially, before there were exchanges, which is still a very common way of trading crypto coins, and which is BTC.me is doing as well, is via over the counter. You basically go to somebody and then you make an exchange face to face, and the actual transaction you do via the client. Nowadays, obviously, and it's also quite well-known fact, there is a big exchange platforms which are basically, they don't have anything to do with the network per se. They are just an intermediary, so you always, to put it simple, you always have to transact coins to a platform like that in order to then continuously transact it to a possible buyer or seller. And the most well-known ones are Mt. Gox, Bitstamp, BTC.me, and Privacy. Well, just shortly talk about the problems. Problem is not necessarily a problem, it's just a fact that is known. What we said before is that changes in the network can only be distributed via the software. It means that I have to convince everybody to get this piece of software with the changes that I put forward. The software being open sourced, everybody theoretically can check, okay, what are the changes, what are the technical parameters of the new piece of software, and then agree or disagree. In order to actually make a change in that network, I need to convince at least 51% of that network to follow me. 51% doesn't mean the amount of clients, but means the amount of computing power. So theoretically, if somebody is able to amass 51% plus n of the current so-called hashing power or computing power of the network, they could, this group or person could theoretically put forward a client version with parameters to their liking. And that is the reason, this has not happened for the Bitcoin network, it did happen for other alternative coins that tried different parameters and got attacked and got taken over, died, changed, were continued with the changed version. There's a lot of stories about 51% attacks in this cryptocurrency community, and they are very interesting because they're not necessarily always, let's say, an evil point or like an attack point to destruct, but there's also stories of cryptocurrencies being adjusted by a discussion that went on in this community, and more or less like a democratic choice of a certain amount of computing power to follow a certain way. Hence a regulation, and this is just a side fact, is people saying that the decentralized network cannot be regulated by any authority. And that is fundamentally not true, because theoretically, if the government right now decides, okay, we take it on that we want to regulate the Bitcoin network, theoretically, again, all they had to do is they had to invest so much as to match exactly this percentage, and then they could put forward parameters to the liking again. The question is, of course, would then the network still exist? Would anybody else follow? That is absolutely hypothetical, but a nice way of thinking about it. But just because, and this is very important also to understand for the economics around it, just because it's a peer-to-peer network and it's a decentralized network and it's open source, does not mean it's fundamentally unregulated. Further topics that I'm just gonna touch very, very quickly, because this is just so maybe you've heard of that and maybe have a question further on, then we can talk about it. But for the arms race, so to speak, the arms race is an analogy of the development of the Bitcoin network in particular, that went from the computational power of using CPUs in the very beginning over using graphical processors to especially programmed so-called field programmable gate arrays. Nowadays to ASICs, which are basically processors that can only do one thing, and it is calculating the function that this network needs in order to proceed. Then, I said before, Bitcoin is only one part of a vast amount of different alternative coins. What is important to know is usually what they differentiate is either they are a fork or a clone of Bitcoin. That means they use the same basic functions, but they have different parameters. Or they use, that's the other part, they use another proof of work, another hash function. And this is mainly the next follow-up to Bitcoin, which is called Litecoin, which uses just another hashing function, but it's basically doing the same thing.